Brilliant. So this is a little departure for me, sort of talking about, I guess, philosophical things rather than sort of more physical stuff. So one of the questions we've been debating is how do we select indicators for soil monitoring, and what sort of framework is going to be suitable for doing this? Now, soil quality seems like a pretty obvious place to start. So, and I understand exactly what soil quality is. So how many of you understand what soil quality is? Oh, no, seriously, we have two people. That's it, two people in the room. Okay, we're going to learn something. So, so the problem is, I guess, really that, so Tom and I each have our own view of what soil quality is. We probably don't have the same view, and that's where the problems come in. So, but what's interesting is that neither does a dictionary. So when you look at the definition of what quality is, it can be referring to excellence, it can be referring to a standard, or it can be referring to a characteristic. And so this makes it a little bit more tricky in terms of what we are trying to think about when we discuss quality. It's a very subjective term, usually thinking about what's better or what's worse. Can we shift this screen on the side? Is that, can we get rid of that or not?
Maybe if you click the you can minimize.
We can minimize it, is that right? We click these three? Let's try that. No? Okay. Move it a bit, can we? Yes, okay. So the quality does matter because of the decision making and subsequently the actions that are taken and carried out. So quality framings are actually quite important. Now I've absolutely killed it, haven't I?
I just have to click on the screen.
Click in the middle of the screen.
Ah, great. Okay, so here's some different types of quality. So 5 types of quality. So when we're having a discussion about quality, which one are you thinking of and which one am I thinking of? And usually that's probably different. So it was quite interesting. So Rachel Creamer and I were having a discussion. I'm thinking normally of number 2, and she's thinking normally of number 3. And so when we're having a chat and having a discussion, we're often at cross purposes. So I put this table together. Let's see if we can shift this out of the way. So this is the busiest table you'll see probably on a slide today. And, oh, there we go. Just managed to get that out of the way. But what I want you to think about is, so I put on the end water. So if we were thinking about water and we were thinking about these different forms of quality, we might have something that is by exception. So this is the difference between perhaps Perrier water and the bubbly water that you're just getting out of the, you know, out of the pump. But if you're thinking about what is exception, what's above a standard, you might be thinking about ultra pure water with water that's not so ultra pure. So you have a standard there, and that makes a difference. And this one, excellence perfection, is about 0 defects. It's about hitting a benchmark where you are you don't want to go below. So it's like a minimum. It's a sort of minimum standard that you want to achieve. Consistency is about maintaining in the same sort of scale. Water companies really interested in that sort of thing. Fitness for purpose. Well, if you are an athlete and you're super fit, maybe you want to choose isotonic water to give yourself an advantage over just plain bottled water. And so all of these are different quality frameworks that can be looked at, and so ultimately it matters because it starts to set and determine the criteria that we use to go on to select the indicators that we use within our framework for assessing soils. And then it affects also the interpretation that we are looking at. So if we take something like fitness for purpose, we might be thinking about a pH threshold that is of importance to a particular crop. And so that then becomes a really important way that we interpret. But if we're looking at the whole of Europe, we might be interested in the pH threshold that's related to what's happening in terms of aluminium coming into solution, because that's a broad geochemical threshold that could be of use and of purpose, and that things below it are going to struggle and things above it is going to be better. And so we have a different framing and a different interpretation. And so putting this together, we're interested in total quality management, and we go through this process of defining a goal, monitoring an assessment, and then selecting an appropriate framework to work within in order to achieve improvement. And also, when we work within our framework, it depends on the purpose, the scale, and who the stakeholder is that we're targeting at. So all these things matter. And so what we started to break down was quality in terms of this sort of total quality framework, but then thinking of what sort of framework in terms of quality are we going to use in order to get the sort of results that we want. And we recognize that with these quality frameworks, we've got different ways that we interpret it. We've got different sort of thresholds or non-thresholds, and we've got different stakeholders that it's more appropriate for. And so we started to create a sort of typology of quality, and we can see these in practice. So the Soil Benchmarks project is very much working in this area of fit for purpose. The Cornell soil health methodology works within that sort of fitness for purpose. The value-based, we have things like the system of economic accounts that the UN use. So they have a different framework that they adopt. And within AI for Soil Health, working with JRC, they've adopted this kind of zero defects, this kind of minimum threshold in order to determine, is a soil degraded or not? And that works very well at a large scale. It might not be exactly what we want at the smaller scale. So, and at the smaller scale, or one of the things that's sort of in between is another area we were looking at is benchmarking. And in benchmarking, really what we're looking at is the distribution. That's all that we're looking at. We're looking at a distribution. We are not using it in the sense of setting targets. We're using it in the sense of context. So if I'm a farmer, and I understand that all the farms around me with similar soils have this kind of distribution, and there's the median, and I'm down here. In terms of setting goals, I probably want to get over there. So I will probably want to improve. And so it's really useful for a soil manager. It might not be of the same use to a policymaker looking at a bigger scale, but it's quite a useful approach for transitioning across scales. So just pulling it together, we've got this idea that not one size fits all in terms of these different quality frameworks. We've got this sort of free from degradation that fits very well at sort of pan-European with more of a policy focus. The fit for purpose is much more at a local scale. And this benchmarking, looking at distributions across different scales, can to some extent help us to cross these scales. So the next time you're having a conversation about soil quality, think about what framing you are using in order to try and convey what you want to convey about quality. Okay. So thanks very much. And you can see there's a lot of people taking part in this conversation. Okay.